Power. We are going to be looking at how we use electricity. And if we want to know what we're actually using, we need to consider how much power we're using. There's a big difference between plugging in an electric stove and plugging in an electric flashlight or a lamp. So we need a way to quantify how much energy is being used. To start with that, we're going to define power as the same units that we've used before. So we're going to start with the name of the idea, just as we've done. So we're going to look at power and the concept behind it. When we looked at power in the more physical sense, we considered the power of, hey, how many pounds can you lift in a second? How long does it take you to run up the stairs? Or something like that, right? We looked at Newton's force over distance. When we're looking at electrical power, it all comes a little bit differently. For electrical power, we're really just still looking at energy per second. Energy per second. But instead of like lifting physical mass, moving it across space, we are going to be looking at energy a little bit differently. We're going to look at energy as how many electrons are moving, how much charge are they carrying every second. When we are looking at electrical energy, we are going to use the same variable in the same unit as the other kind of energy. So our variable is still going to be P, and our unit is still going to be the watt. So if you were keeping your notes on all of these concepts, we can add this. Power is energy per second. We use the variable P to represent it in our calculations, and we measure it with units of watts. A watt is abbreviated with a W, but we are also going to use a kilowatt. It turns out just 1 watt in electricity is not a lot. So I'm also going to add this kilowatt onto here because we're going to need that. So a watt is a joule per second. A kilowatt is 1,000 joules per second. So a kilowatt is equal to 1,000 watts. 1 kilowatt is equal to 1,000 watts. So this is what you might want to have written down and available. I'm also going to include the equation that we are using from that. You have had access to this in your book. You have got this in that summary that I gave you. But for those who do learn better on video or seeing me present the ideas in this way, we'll put it here so that you can put it in your notes. So in electrical terms, power is equal to voltage times current. I'm going to write that down here. Power is equal to voltage times current. I'll include the units for each of those. Power is going to be in watts, voltage is still in volts, and current is going to be in amps. So to get watts, you're going to multiply your volts times your amps, and that tells you how much power you're utilizing. So for example, if I was told that I had a 2.1 amp charger that was using 120 volts, we'd be able to take a look and see how much power that was using. Right? Now, we've got to be really careful when we look at our different devices. If we are talking about the volts and amps, we need to make sure that we pay attention to how much is going in versus how much is going out, and so on. We'll want to take a look at our devices carefully when we get around to that, and we'll have some resources for doing so. But in this case, our power would just be equal to 2.1 times 120. We'll go ahead and calculate that out. $252 watts would be what we'd be looking for there. And that's quite a lot of watts. 2.1 amps at a full 120 volts is a lot. Just for a point of reference, a sort of standard incandescent light bulb would come out to 60 watts. We're looking at a 60 watt light bulb. And so that would be some pretty crazy power usage right here. This would be about 4 of those regular light bulbs. All right. We'll talk a little bit more about how that gets measured in our next video. Thank you for listening.